All right, so you type something into a search bar, hit enter, and boom, results. But have you ever stopped to wonder how that actually happens? Today, we're pulling back the curtain on the hidden engine that powers pretty much every web search you've ever done. It's called the crawler indexer architecture, and we're going to dive right in. No, I mean, really think about it for a second. The internet isn't some neat, organized library. It's a chaotic, constantly changing universe of information. Billions of pages and more are added every single day. So how on earth does a search engine keep up with all of that? How does it find that one page you need? It's a massive, massive problem to solve.
Well, the answer to that huge challenge is actually a surprisingly elegant system. It's called the crawler indexer architecture. And really, this is the blueprint, the fundamental design that brings order to all that online chaos.
So at its very core, it's all about this simple but really powerful loop. It all starts with a scheduler. Think of it as the boss, making a list of URLs to visit. That list goes over to the downloader, which is the worker that goes out and grabs those web pages. And then those pages get sent to storage. That's where they get analyzed, and this is the key part, new information gets sent right back to the scheduler. It's a cycle that just keeps going. So let's break down each of those pieces.
Okay, let's pop the hood and take a look inside this engine room. We're going to see what each of these core components is actually responsible for.
So first up, we've got the scheduler. You can pretty much think of this as the brains of the whole operation. Or maybe an even better analogy is a giant, super organized to-do list. It keeps this massive prioritized queue of every single URL it needs to visit. And it's always deciding, okay, what's next on the list? Right, so once the scheduler picks a URL, it hands it off to the downloader. This thing is the tireless worker bee of the system, you know? It has one job, and one job only. Go out onto the World Wide Web and download the raw content of that page. Simple as that. Okay, so the page gets downloaded, then what? It gets sent to storage. And this is way more than just some digital filing cabinet. This is really where the magic happens. The system tears the page apart, analyzes all its content, and then indexes it. It's basically creating a giant searchable map of what's on that page. And here's the really crucial part. It also finds any new links on that page and sends them right back to the scheduler's to-do list. See how the loop closes? So there you have it, the three main parts, the brain, the worker, and the library, if you will. Now let's put it all together and see how this information flows, how they all work together to create this seamless, self-perpetuating machine. And this is that beautiful loop in action. It's so simple, right? 1, the scheduler provides a URL. 2, the downloader goes and fetches the page. 3, storage indexes it. And 4, here's the brilliant part, storage extracts all the new URLs from that page it just indexed. And where do those go? You guessed it, right back to the scheduler. And the cycle starts all over again. It's this self-sustaining system that just endlessly discovers the web. Now, of course, it gets a little more sophisticated than that. To be really efficient and, polite, which basically means not hammering any single website with too many requests all at once, the scheduler often gets split into two. You can have a long-term scheduler that's making the big picture decisions, and then a short-term scheduler that handles the immediate what's next queue. It's kind of like having a master planner for the whole project and then a shift manager making sure the day-to-day work gets done smoothly. But, having just one single central system like this has its limits, especially as the web just exploded in size. New challenges came up that needed a completely different way of thinking. They needed a distributed approach. And a really fascinating early example of this distributed idea is something called the harvest architecture. The whole idea behind Harvest was, instead of having one giant crawler doing everything, let's spread the work out. It was designed to be way more efficient and solve some real-world problems, like having a bunch of different crawlers all hitting the same server at the same time. And this new way of thinking is what we're seeing here. Instead of one big central system, you have what they called gatherers. These are smaller, localized systems that just collect info from web servers. Then you have brokers. And a broker's job is to provide the query interface. It goes out and asks the different gatherers for their information, combines it, and serves up the search results. It's a really clever way to separate the job of collecting data from the job of searching it. So the big takeaway with Harvest is this clear division of labor. You've got your gatherers out there collecting and extracting, indexing info. You've got your brokers, which provide the actual index and the interface for you to search. And then you have other components, like a replication manager to help it scale up, and an object cache to smartly store popular data to cut down on network load. Every single part has a very specific, defined job. And the huge advantage of a model like this? Flexibility. A broker doesn't have to talk to every single gatherer out there. It can pick and choose, maybe only pulling information from gatherers that focus on specific topics. And this makes it way, way easier to build specialized, topic-specific search engines. You could have one just for academic papers, or another one just for news sites. All right, so we've been deep in the weeds with the technical blueprints. Let's zoom out for a second and talk about why any of this actually matters to you and me, in our daily lives online. At the end of the day, here's the thing. It doesn't matter if it's a simple crawler indexer loop or a super complex distributed system. This fundamental process, this relentless cycle of discovering, retrieving, and organizing, that is the engine that turns the vast, chaotic World Wide Web into the incredibly useful, searchable tool that we all rely on every single day. And that kind of leaves us with the final question to chew on. This architecture was designed for a web of static pages and hyperlinks. But the web today? It's a totally different beast, right? It's full of dynamic apps, private data, and now tons of AI-generated content. So what do you think the next huge challenge is? What is the next generation of crawler architectures going to have to solve?